Hello, in this video, I want to talk about how to fit linear mixed models using the R package, lme4. Okay, let's go to the R documentation first. Okay, so this is the R documentation for package lme4. So it is for fit linear and generalized linear mixed effects models. So mixed effects models are another type of model for correlated data. So they apply for, say, longitudinal data. They apply for multi-level data. This lme4 package has function to fit linear mixed models and generalized linear mixed models. Okay. And from the content, you can see it has a lot of functions and data sets. So this glmer is for general linear mixed models. I think the lmer is for linear mixed effects models. Okay, so for this video, we'll talk about the lmer function. Let me see. Hopefully I can locate it quickly. Sorry about the wait. I think it arranged by alphabetical order. Oh, here. So this lmer function, you can see it has formula data and REML. As you know, for mixed effects model, you can use ML, the maximum likelihood estimation, or REML, the restricted maximum likelihood method. Okay, and you have the control, and this is a very detailed control function. You can specify how you want the algorithm, to run. Okay, it has superset, it has weights, and NA action, contrast, and that's it. Okay. It doesn't have a way to specify the correlation structure for the repeated measures. So that's a limitation for the lmer function. It only has a way to specify random effects. Okay, so if you're familiar with the math theory of linear mixed model, you know there's a G and there's a R, two correlations. For this one, it only has specification for the random effects, but not the kind of the serial correlation between the repeated measures. Okay, so you can take some look at the documentation. So the value or the output for this function is a class MER mode, more specifically an object of a subclass LEMR mode. Okay, so it's a very specialized object defined for exactly this function. Okay, and you can see here are some sample syntax. And for this video, we're gonna just play with the very basic model fitting. Okay, let's go back to the RStudio. Okay, to use the lmer function, first you need to load the library lme4 and then set seed and create a a data set and create a random effect, intercept random slope, get some residuals, create the dependent variable, and this is what it looks like. So for linear mixed models, y must be a continuous variable. Okay. All right. So to fit linear mixed model using lmer, you can see you specify the formula y tilde x1 plus x2 plus time plus. Now this is how you specify random effects. Okay, it's parenthesis 1, the vertical bar, and subject. Okay, and data equal to data here, remo equal to true. So we're telling R that we're going to use the remo method for estimation. Okay, so it's a very quickly fit the model. And if we want to also do the model we just fit only has a random intercept. That just because of one vertical bar subject. But we want to random intercept and random slope, then we have to use these command like parenthesis 1 plus time, then vertical bar and subject. Okay, so here it become random slope and random intercept. Okay. However, as we have said, like for GEE or in the SAS proc mixed, we can specify different correlation structures like AR1, exchangeable, unstructured, etc. Unfortunately, lmer doesn't have that. So we only can approximate the correlation structure here by like using some special syntax here. So if we want to say mimic a AR1-like structure, random slope for time with no correlation with intercept, then we can use this formula y tilde x1 plus x2 plus time plus parenthesis 1 vertical bar subject and plus vertical bar 0 plus time vertical bar subject. Okay, so it's a little bit awkward, but that's how we can mimic AR1 correlation structure. And also this is the unstruct covariance. We can do it by using this this way, just 1 plus time vertical bar the subject. Okay, and then we can take a look at the summary. So if you use a summary to show the output, it gives you this information, including the formula, and tell you the estimation method and the convergence criterion at convergence, and give you the residual statistic, scale the residual. Okay, so and random effects also give you the fixed effects, but there's no p-values. So to make the inferences, you have to do some additional work. Okay, so here this similar. Now we fitted several different models. I'm refitting all the models because now you can see I'm using the maximum likelihood ratio, maximum likelihood estimation, because for all these models, I specified remo equal to false. Okay, so the reason why I want to fit these models again using maximum likelihood method is because I want to apply the AIC function to calculate the AIC value for model selection. So you can just use AIC and put all these model objects in there. It can calculate all the AIC values. Looks like the AR1 correlation structure has the smallest AIC value. So that is the best model based on the AIC value. All right, so this is kind of the first video on the lme4 package, and I'll make another video to utilize all the functions in that package and to do more like additional analysis for linear mixed model. Thanks.